So we're going to look at the ANOVA calculations. So we have A, B, and C. So these are called treatments. And the variation that occurs in between these treatments is called the sum of square root between. We usually write SSB. Then we could have figures 2, 1, 2, 2, 3, 2, 1, 2, and here we have 3, 3, 1, 1. So these variations in between within the treatments are called sum of square within. Okay. So to start with, you need to total up each column, sum them up, and square total. So help me. What is the total here? 2, 4, 6, 7. Then number them 1, 2, 3, 4. So there's a 4. Then square each individual. 4 plus 4 plus 4, 12. Plus 1, 13. We're squaring them. This is 9 plus 1, 10. 10 plus 4 plus 4, 18. So this is 18. And there are 4 in this. Then add them. 5 plus 8. 5 plus 3 is 8. Are you seeing what we are doing? Here, total up, 3 plus 3, 6. 6 plus 1, 7. 7 plus 1, 8. Then you count them. 1, 2, 3, 4. There are 4 observations. All right. Then later on, you square each individual. 9 plus 1, 10. 9 plus 1, 10. So this is 20. So you total up. This is where we have the sum of square total. This is summation of x. What do we get? 23.
23.
Then n, 12. And summation of x squared. We have 11 carry 1. So 51. Okay. Anyone lost in coming up with this table? Okay. So please make sure that your cameras are off. Then we're able to do the calculations here. So we have sum of square total. Sum of square total is given by what? The variation in x. So summation of x squared minus summation of x to the power 2 over n. So this is 51 minus 23 to the power 2 over n, which is 12. And sum of square treatment is the same as sum of square between. So the variation that is existing in between. So here we have what? Sum of square between is each treatment. You square it over n minus the correction term divided by capital N. So this is 7 squared over 4 plus 8 squared over 4. The next one is what? 8 squared over 4. What do we get? We subtract the correction term, 23 squared over what? 12. Please help me with the figures here. Help me with the figures.
So it's 44.25 minus 44.08. Hello?
Yes, please. What's the total?
I got 44.25
Here,
minus.
what was it? 6.92. And here, so this is basically 23 squared over 12 is a quotient term.
44.08.
That's 44.8, 44.08.
44.08.
All right, okay. So 51 minus 44.08. That's how we got that. Then here, 7 squared plus 8 squared plus 8 squared divided by 4. We have 44.25 minus 44.08. What are we getting? 0.17. Is that what you're finding? Is that what we're finding? All right. So before we use those figures there, I just want you to understand how to balance out. So I'm not going to use.
Sorry, how did you find the answers in the boxes? My network, because I lost my network.
We just computed using the figures. I think I'll send the video, but we just computed using the figures that are there. 51 minus 23 squared over 12. That's how I found that. 7 squared over 4 plus 8 squared over 4 plus 8 squared 4 minus 23 squared over 4 over 12, we get 0.17. So this is a sum of square in between. Unless you found something else. Did anyone find something else? Okay. So my key interest is understanding firstly how to balance up. Okay, so this is a one-way ANOVA, which has treatments and blocks. So the number of treatments is called our K. These are called populations. And the number of observations is called our N. It's called observations. So the ANOVA table has the following format. We have the 3 sources of variations, which are in between, and in and within, and the total. And the sources of variations have acronyms. This is sum of square, between, sum of square, within, sum of square, total. And we're given our degree of freedom, which is given by k minus 1, n minus k, and n minus 1. The mean of squares is simply the quotient of these two. This is called a mean of square root, between, mean of square root, within, and finally the f calculated will be mean square within into mean square between. So here, suppose the figures that we found here, sum of square between, we have 60, and the sum of square total, we have 100. So how do we balance up this? balance up this. We're going to fill in this table. So between, within, and total. So SS, degree of freedom, mean of squares, and F calculated. Are we clear so far?
Yes.
So now let's fill in what we have. What do we have? Okay, so what is our sum of square between, according to this data? 60. The total, 100. Then within is the difference. What are we going to get there?
40.
40. Degree of freedom for the between k minus 1. The number of populations here are 4. So 4 minus 1. Then here, n minus k. What is our n here? 12. 4.
12.
So 12 minus 4 is 8. Then here, when you add 8 plus 3 is 11. Then the mean is simply dividing this in there, this in there. So 3 into 60, how do we get? 20. 8 into 40, how do we get? 5. Then
And
you,
the N is 16.
oh, the n is 16. So let's go again here. K minus 1. 4 minus 1 is 3. Our n is 16 here. So 16 minus 4, how do we get?
4.
12. All right. Good. Thank you for that. So 12. So this is where I put the 12 there. And 3 plus 12, we'll get 15. This must also tally with n minus 1. So 16 minus 1 is 15. Then we start dividing. 3 into 60 is 20. About 12 into 40, what are we getting?
3.3.
3 point what?
3. 3.
3, 3. Okay, 40 divided. We get 3.33. Then finally, divide the 20 divided by that answer. We're going to get what? 6.
Come again on that one. Didn't get it.
All right. So, anyone behind so far?
Yes. The 12 coming from?
Where's the what?
The 12 coming from. Aren't we supposed to do 16 minus 1 on the end?
16 minus 1, which is 15, yes. You can either do 16 minus 1, which is what?
But I can see.
Or you can add 3.
Isn't that a 12 there?
12 was wrong because when you count them 1, 2, 3, 4, these are 16. Somebody corrected it. So 16 minus 1 is 15 here.
Okay, all right.
Okay.
Let me just see the previous calculations. I take a screenshot.
Okay. Any questions?
Okay, thank you.
Is it clear? Okay, so after we have solved that, we now need to learn how to conduct an ANOVA for this data. So our task now is to conduct an ANOVA test. So we use the number of populations. How many populations are there? There were 4, right? So you say step 1, state the hypothesis. You simply say mu1 is equal to mu2 is equal to mu3 is equal to mu4. And here you say at least what? At least one is different. Number 2, you set the level of significance. Suppose you're given 5%. Number 4, you read the table for the F, the critical value. So this is how we read it. Use the same 5%, but the degree of freedom in coordinates. So we had what? 3, 12. That is a job of the what? That is a job of the degree of freedom to read the tables. So 3, 12. So when you go to the F table, make sure that it's 5%. Then 3 and 12, where do they meet? They meet at what? 3.49. So 3.49, that is where we're going to read. So this is 3, 12. So 3.49. So whenever we accept, it means there's what? No significant difference in the means. Whenever we accept, there's a significant difference in the means. So step 4, calculate the F calculated. So our F calculated is what? 6. So you write 6 squared. This is where the table comes in if you want. 6. Now, where is the 6 coming from? It is in the rejection region here. So what is our conclusion? We do what? We reject HO. What does it mean? We have a significant difference. There exists a significant difference. All right. So this is a 20-mark full question. It's very easy. So I'll take you through the question that is coming in the exam. This one. So now, Papa, if you don't get it, what do you do? Memorize with terrible exactness, just the answers. I post what if you answer. Okay. So when you have this, what do you do? We get the totals. Right? Dora, are you here? Okay. What do we do? We get the totals. Let's get the totals. Mali, what totals do we get? Summation of x, n, and summation of x squared. Let's do this together. Please, those ones who are very new and BID, I've sent a link just for you only, so that we can be discussing on our own some issues that are for you. All right. So we total up in the first column. What are we going to have? 6 plus 5 plus 4 plus 5 plus 6 plus 4. This is 30. I'm going to do the first column.
Calling.
The ladies will go
Sorry,
ahead. And the gents will go there.
Calling.
Yes, please.
Sorry that I've taken you back. My mic was not working. So my network had cut. May you just restart the question? You had called for my name, then I was trying to unmute. It couldn't go through, so I had to change my settings. Then I zoomed out.
Okay, so I'm saying this question is what we want to try. It's coming. So you need to just see what's supposed to be done. So whatever I'm going to do in the first row, you try to do it in the second, and the gents will do it in the third, so that we move fast. So the first thing is you sum with
The second question.
6 plus 5 plus 4 plus 5 plus 6 plus 4, we get 30. Then count how many there are. 1, 2, 3, 4, 5, 6. There are 6. Then square each of them. Okay, 6 squared plus 5 squared plus 4 squared plus 5 squared plus 6 squared plus 4 squared, get 154. So this is 154 we're going to get there. Now quickly help me in this so that we move fast. The gents go there. Now just help you with.
Yeah, we sum up here. I
Uh-huh.
think I sum up on market research. I found 27.
Please give me accurate figures so that we don't.
27,
Uh-huh.
6.
Then here what?
That's 36. 36.
Uh-huh. And the total here. So another question, you need to only take 10 minutes to finish it completely. This question is coming, I repeat.
$123.
Mm-hmm. And here.
It's 218.
Someone else to confirm, I'm not sure.
So let's total up here.
Yes, I found 218 as well.
This is 18. Total up here. So summation of x and summation of x squared. So
Sorry, I want us to sum up.
yeah, sum up, we'll quickly finish it. We're having another class at 19:30, so I don't want to eat up time. Avoid overrunning.
Can we get a screenshot? Sorry for delaying it.
30 plus 27
Thank you.
plus 36. 93. I don't know how you're taking long to do the straightforward things. 154 plus
Summation of x squared is 495.
18. 495.
495.
Okay. So the summary of what we have there. Okay. This is 495. This is 18. And the first one was what? 93. Then 30, 27, 36. 30, 27, 36. 30, 27, 36. Okay. The 93. 154, 123 to 18. 154. 666. Now these numbers are down here, may not be really important. 123. So this one here, can somebody remind me, how do you find the sum of square total? Quickly. Summation of x squared and a summation of x to the power 2 over n. So this is 495 minus what? 93 to the power 2 over 18. The sum of square between will be what? Summation of each treatment over its respective n minus a correction term. Okay. So here we have 30 squared over what? 6 plus 27 squared over 6 plus 36 squared over 6 minus 93 squared over 18. So let's compute quickly. 495 minus 93 squared divided by 18, you find 14.5.
14.5.
All right. Then here, what are you getting? So 93 squared over 18 was a correction term, which was 480.5. So here let's do 30 squared plus 27 squared plus 36 squared equals divided by the common denominator, which is what? 6. So this is 487.5 minus 480.5 minus 480.5. We get a 7. So what do we have here? Sum of square total is got what? 14.5. Sum of square between, we get a 7. So this is going to give you in the exam. I don't know why I'm teaching you this, but it's still going to simplify that. It makes this course a little bit boring sometimes. Okay. So the source, and here we have SS. Here we have degree of freedom. Here we have mean of squares. And here we have F calculated. So what are the three sources? Between, within, and total. What is the sum of square between? 7. Total, 14.5. Can you help me? Any questions so far before I proceed at this point? Any questions?
I have a question, please.
Mm-hmm.
Yes, I'm looking at how this was calculated with Mr. Sabao. I wanted to find out, is there another method of calculating this? Because I'm getting confused now.
Mine is simpler. What he did is this. We got this. He did this. We got 7.
Yeah.
And here
Yeah.
we got what was the other one? 7 and this is sum of square between 14.5 sum of square total. All right, it's the same thing.
Yeah.
Sum of
It's the
square
same thing.
treatment over n. That's what we are doing. 30 squared over 6 squared over this. And as a correction term. I'm just more systematic.
Okay.
Then here,
Okay.
total 9 and 5. It's what we're doing here. So 4 and 5, we got this 14.5. How different is this?
Okay, it's not very different.
Yeah. Then
Okay, no.
the difference here,
7.5.
14.5 minus 7 is 7.5. Then our degree of freedom, k minus 1, how many? What is our k here? The number of columns, how many are they? 3. 3 minus 1? 2. Okay. 18. 18 minus 3. What do we get?
15.
And in total, actually, we get what? 17.
Mm.
Write this in there, 3.5. 7.5 divided by 15. What do we get? 0.5. Okay, then we divide 3.5 divided by 0.5. Our F calculated is what? 7. Okay, let's conduct the ANOVA test. Remember, at 5%, which is a common, let's read our table. It will be at what coordinates? 5%, 2 comma what? 2 comma what? 15, isn't it?
15.
So let's go to our table. We know how to read the F table. It's the easiest table to read. So 2 comma 15. So we go under 2 and under 15. What is the reading? 3 point what? 3.68, isn't it?
3.65.
So let's conduct the whole ANOVA so that we get our full 25 marks. I'm very happy that we already know one question that we've done, which is coming in the exam. mu1 is equal to mu2 is equal to mu3. And here we say at least 1 is what? 1 is different. That's step 1. Step 2, set the level of significance. Level of significance is what? 5%. Okay, step 3, set the decision rule. Decision rule is reject HO only if F calculated is greater than what? What we just read, 3.68. Okay, which we calculated 3.68. You know where it's coming from, right? You know where it's coming from, isn't it? 2 comma what?
Yes. 15.
2 comma 15. Then we go to step 3, calculate the F, which we already calculated. What was our F calculated? For 7. Step 5, make a conclusion. Since F calculated, where is F calculated? Is it inside here or in the rejection region? It is here. Since F calculated, which is 7, is greater than what? 3.68. What do we do? Reject HO. Never reject HO. What does it mean? There's a significant difference in the means. So we go to solutions. Let's see whether we're getting the same answers. This is total 25 marks. So here is this question. The question is use a 5% or 0.05 to test whether there's a significant difference in the what perception of the 3 groups. So although he's not very smart, we are going to conduct a hypothesis testing. So the tables I did, get the totals and square them. Get the square totals, you remember, SSB, SS total. Then we conduct an ANOVA test. All these are already in the table. So when you do a table, you find your F calculated to be 7. So it's calculating these ones independently. 0.5, this is a mean square W, which we already found here when we go to our ANOVA table. So we started first by finding the sum of square between 7. Let's go to his computation. Sum of square between 7, correct. We go to sum of square total, 14.5. Is that what we found? Sum of square total, 14.5, correct. Sum of square within 7.5. Let's check, did he find 7.5? Sum of square within 7.5. It's this one here. But where is it in the calculations? It's very jumbled, so it's very easy to find. Then the degree of freedom K minus 1, 3 minus 1, which is a 2 here. You found degree of freedom for this one is 15. So we found those degrees of freedom, 15 and 2. And we divide this, and this is a mean square between mean square within 3.5 and 0.5. Did you find that? Okay, 3.5 there and 0.5 there. Then you divide this in there, you find the F calculated. So F calculated is what? 3.5 over 0.5, which is 7. Are you seeing? how systematic the table is. It finds everything. Then you conduct the whole test. So the critical point is the 3.68. So when you go to the table.
Yes, where is that 3.68 coming from?
From the table, this one here. 3.68. When we go in this table here, remember the degree of freedom comes from the ANOVA table. So when you go here, 2.15. So when you read at 5%, 2.15. So this is where we get this. Remember where we got it from? Do we remember? The rest of you, do you remember?
Okay.
Yes, we got it from, yeah.
Mr. Collins, maybe I missed when you were first sharing on the F table. Did you share it with us? Huh?
Yes, I shared all the
I
tables.
don't think so. Okay. All right.
I think we got it from the K.
I have done the entire table. So this question, like it or not, is coming 25 marks. Okay. Tomorrow, those who are coming for the physical classes,
Mr. Collins,
we're looking at this question, which is coming on regression analysis, 25 marks. So already, with these two questions, you're already clearing the exam. So we end here. Those that are doing financial accounting can remain.
just a question, Collins, before you end. I joined in late. Please make sure you share the video. My question is the same question I asked in class to say, is there a possibility that they'll give you without giving, like the way you wrote them down, you wrote
No, here the only
the
difference,
square of the sum.
he will give you the sum of square. He will spoon feed you. But I just want you to know how to do it even without being spoon fed. He is going to spoon feed you these solutions that we did down there. He's going to give you some of square block, some of square within, some of square between, some of square total. He'll give you all of them. He always gives.
So you might as even well give us a diagram and just remove some numbers and the like.
Alternatively, yes, he may give you a diagram with missing figures, then you balance it up. Yeah. So this activity 4 is very important. Please release me. Let me end here now.